Hi guys, I'm Kumar and today we'll be talking about counting and arrangement. So, one of the most popular questions in arrangement and selection is basically you're given two sets of uh, items and then you're given a certain set of conditions in which you have to select or arrange items. Okay, to understand better, let's look at this question. So, we have three boys and four girls who are standing in a line to take a photo. How many ways are there for them to stand so that no two boys stand next to each other? Okay. So what we are given is we have two sets of items, let's say. So we have three boys. So I have a B, and a B. And I have four girls. G, 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 G. And my condition is no two boys should be standing together. So for example, something like B, G, B, G, G. This would be acceptable. However, if I make an arrangement where people are standing like this is not acceptable because here boys and boys, the two boys are standing together. This is not acceptable. So the question is, how do I arrange all this? Okay. So to do these kind of questions, or rather any question, there are two things that you have to start with. First, you have to have all the basic tools that are needed to solve such a question. A question of this kind, you have to know three basic tools. One is factorial, the combination, and the permutation. Okay, we'll discuss these shortly. The second you'll have to start is with a plan. Okay, how do you inbuilt all the conditions into the question so that you can have arranged set of thoughts on solving the question. So after we look over the tools that we have, we'll go over the plan. Okay, so let's look at factorial. Okay, um, n factorial is represented by the multiplication of numbers starting from 1 all the way up till n. So if I have, let's say, something called a 3 factorial, this is nothing but 1 into 2 into 3. This is equal to how much? 6. Similarly, if I have something like 5 factorial, that will be 1 into 2 into 3 into 4 into 5, which will be equal to nothing but 120. Okay, so what you guys can do at home is find out all the numbers up till 10 factorial. So what is 7 factorial equal to, what is 8 factorial equal to, what is 9 factorial equal to, what is 10 factorial equal to. This will give you enough practice to to find out and remember some of the basic factorials. Okay, this could be very helpful to you in the questions. Okay, we are done with the first tool. The second tool is basically our selection tool. Okay, this is the formula that we use when we have to select certain number of items from a given group. For example, suppose I have a class of 13 people, okay, and I have to make a basketball team of 5. Okay, the way I select the team is denoted by 13C5. Okay, and this is nothing but equal to, look over the formula. So on numerator I will have a 13 factorial. In denominator I'll have 5 factorial. This r is nothing but the number of people or number of items I'm selecting, and n minus r is 13 minus 5, which is 8 factorial. So the solution that you'll get for this will be the number of teams that you can form out of 13 people with selecting 5 people. Okay, so this is basic selection. Now look at what is arrangement, or what is called a permutation. Okay, so when we are doing selection, we are not considering the arrangement, right? We are selecting 5 people, but we are not deciding who will play at 90 degrees, who will play at 45, who will play at 0. That we are not doing. But when that comes into the picture, what we do is we do arrangement. Okay, we do not use this formula, we use this one. Okay, for example, suppose I have to suppose I have 5 alphabets: A, B, C, D, and E. And I have to form three letter words out of it. Okay. Now see, the way it is different from the previous case that we discussed. For example, I select B, C, D. Now this same thing can be used to make a word which is BDC or CDB. Now understand, in both the cases, the number of selections or the item being selected are same. You have B, C, and D. But the words they are forming are entirely different. This is because the arrangement becomes a factor. That is why you'll note that the number that permutation or number of arrangement is always more than the number of selections. This is so if we use this formula and we find out how many words we can form, this will be 5, which is the total number of alphabets that we were given in the starting. And then we select 3 out of that to make our words. This will be nothing but 5 factorial by 3 factorial. Now if you guys have practiced factorials, finding 5 factorial and 3 factorial will be very easy for you. So you can find out how many ways I can arrange these words. So if you guys study these tools properly, you'll be able to understand how to do basic arrangement, how to do basic selection, and how to do selection under particular conditions. Okay. Now that we are done with the tools, we'll work on the plan. Okay. Okay, so I have 3 boys and 4 girls who I have to help them stand in the line, and I have to make sure that no 2 boys stand next to each other. Okay. Now the point is, there are many ways of approaching this, but the simplest way is, and remember this, in a question like this, when you have 2 set of items and you have been asked that one set of items cannot stand beside itself, or cannot two items of the same set cannot be put together. What you do is you start by arranging all the items in the set which do not have to follow the condition. For example, here I have 4 girls. So what I'll do, I'll arrange 4 girls and I'll keep a space between all of them. Okay. Also understand that there will be a space on the left of the first girl and there will be a space on the right of the last girl. Okay. Now let's understand how this methodology helps us in solving this question. See, if I do this, if I arrange the girls like this and then I start putting the boys, okay, I can only put boys in these spaces. It means if I put a boy here, I can only put either here or here, and automatically there is a girl that comes between them. Okay. Now some of you may ask, what if there is no, I don't put anybody here? What if I put a boy here, a boy here, and a boy here? What is happening here and what is happening here? Okay. So what exactly is happening? If you do not put a boy here, then basically there is nobody standing between these girls. Okay. So your arrangement will be something like B, G, 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 B, G. Do you understand? So basically what you're just doing is you're not putting anything, which means there is nobody between these 2 girls. But you're, oh wait a minute, there's a B here as well. Yeah. So our basic condition is always satisfied if I go at these kind of arrangement. Okay. Okay, so this is how we answer the first question. So the first we'll arrange the girls because they have no condition on them, and we'll keep a space between any 2 girls, and we'll take a space on the left of the first girl and the right of the second girl. What do we do next? Okay, so let me draw that again. So I have 4 girls. Okay, after the girls are arranged, now I have 5 spaces. Okay, the second step is to select at which 3 spaces I'll be putting the boys, or basically I will be selecting my spaces. Okay. The reason I've put them separately is we'll be doing one step at a time. Okay. You have to arrange girls first, and you have to select the spaces in which you put the boys, and don't forget that after you've put the boys you also need to arrange them. For example, suppose I put b1 here, b2 here, and b3 here. Now this is one selection that is possible, but I can also arrange the boys with b2 here, b1 here, and b3 here. As we have discussed before, the spaces that have been selected are same, but the arrangements are different, right? And we have to arrange the boys in this question, understand? Okay. So there are three parts to this question, and we'll attempt each of them one by one. Okay. So let's start with the first part. What I need to do is I have to arrange four girls. Okay. Now the basic principle here that we use, if we are arranging n items without condition, that can be done in n factorial ways. Okay. For example, I have, let's do the alphabet example. I have A, B, C, and D. Okay. And I have to create a 4-letter word, right? What I can do, I can select any four of the alphabets to go at the first position, right? After my first selection is done, let's say I've chosen B, or I could have chosen anything. What I'm left with is three alphabets. What I can do is I can select any of the three alphabets to go at my second place. I'm left with two, and I can select any of those two to go at my second last place, and the one who is left will go into the third space. Now if you remember the definition of factorial, this is nothing but 4 factorial. Now the arrangement of girls is similar. I have 4 specific places where I have to put the girl, and then I have to arrange within them. Therefore, the number of ways the girls can be arranged is the same as arranging 4 items without any condition, which is 4 factorial. Okay, so we'll keep this here, and now we'll go to the second and third part. Remember, the first part was arranging the girls, second part is selecting the spaces, and third part is arranging the boys. Okay, now after the girls have been arranged, what I'm left with is 5 blank spaces, and what I have to do is select 3 to place boys. Okay, so the selection we have studied can be done in 5C3 ways, right? And the formula for that is what? If you remember, it is 5 factorial by 3 factorial into 5 minus 3 factorial, which is nothing but 5 factorial by 3 factorial into 2 factorial. Okay, so this is my second part. All right, third part is still left. Okay, once I've selected my spaces, the only thing left to do is arrange the 3 boys. And arranging the 3 boys is same as we had studied before, arranging n items without condition. So the 3 boys can be arranged in 3 factorial ways. Now that we have covered all the 3 important steps, we'll come up with the final answer. Okay, so we had 3 steps: first, second, and third. Okay, The first step, we arrange the girls, which could be done in 4 factorial ways. Second step, we selected 3 spaces, which was 5 factorial by 3 factorial into 2 factorial. And the third thing was we arranged the boys, which was done in 3 factorial ways. Now there is nothing left but to solve this, and this can be easily solved. You can solve it like numbers. So this gets cancelled out, 3 factorial. Okay, we know that the value of 4 factorial is 24 and value of 5 factorial is 120. 2 factorial is 2. So if you solve this, you will get nothing but 1440. So this is your final answer, and this is the number of ways I can do the arrangement given under the set of conditions. Thank you. Hope you had understood the concept of factorials, permutations, and combinations. It can help you do a lot of questions from your textbook as well as Olympiad questions. Thank you and have a good day.